Hello and welcome. In the previous episode, we discussed how Kubernetes assists container-based applications to abstract storage from code through ephemeral and persistent volumes. If you missed that episode, you can view it by clicking on this notification right up here. In today's episode, we will discuss how to factor out and abstract application configuration data from code, because most applications have some sort of configuration that needs to go with the application, but we don't want to hard code them inside the application because obviously if any of the information changes, then we have to recompile and redeploy the application. And furthermore, we definitely don't want to have our secrets to be inside the application. So we need to come up with some strategy. Let's see how Kubernetes can assist us on that front as well. And that is a discussion for today's episode. We will be discussing configuring pods with environment variables, managing application configuration with ConfigMaps and what ConfigMaps are, working with sensitive data using secrets. So secrets are specific types of object in Kubernetes. And lastly, how to encrypt secret data at rest. So although Kubernetes provides secrets, by default, it does not actually encrypt those. It only encode them using base 64 algorithm. So which means that if a hacker is able to get access to the etcd data, they can easily decode those information, those secrets. So we need a strategy to encrypt the data when they are at rest in the etcd. So let's start with environment variables because those are the most basic types of configuration vehicles for us. There are two types of environment variables. The first kind is user defined. You define them in the pod spec for each container, and they're defined in the format of name and value. They can also be system defined, and Kubernetes define those, and they contain names of all the services available at the time of the pod was created. And then they are created at container startup as Linux environment variables, so you can use them like any other Linux environment variables. One disadvantage of using environment variables is that they cannot be updated once the pod is created. So if the value is changed, then you need to change your pod definition and then redeploy that definition. Now let's see what happens. How do we actually define these environment variables? And this is an example. You can either use deployment or pod in our YAML, and under spec for the containers, then we can then define our environment variables. So under env colon, and then we define as many environment variables as we need. So name, dash name, and then whatever the name that you want to assign it to, in this case, service host name. So this pod will be consuming some service. And then the value of that server is server1.acme.org. And the next value or the next name is service port number. So we need to know what port number we need to this application to connect to. And the value is 9001. So let's go through what happens if we compile this YAML, kubectl apply -f, and the name of this YAML file here. So it goes again through the API server, and goes to kubelet contacts CRI. CRI creates the pod. And then at this point, kubelet again consults the definition of that pod, and it sets the environment variable in the Linux environment. And then once that's done, then the environment variable will contain our defined environment variables here. And finally, CNI creates the networking stack for our pod, and now pod is able to start and function. So one thing that we can do is to test that, we can SH into that pod, and then we can look at, say, print environment, and then those environment will be read from memory, and then we can display them over here. So any application or this pod, any application that are part of this pod then can read those environment variables and use them. Another way to manage our configuration, application configuration, is through ConfigMaps. And they are very flexible, as we will see. First of all, a config map is an API object used to store non-confidential data in key value pairs. They can be created either from literals or from files, and I'll show you both how we can do that. They can be consumed inside pods as either environment variables or be mounted as volumes. And this is very useful. For instance, if you have part of your CI/CD deployment, you want to set up your databases, and you have a lot of configuration information, you can put them all in the config map information and then read them all at once and then set your database or your web server app very quickly, very conveniently. The data is stored in config map cannot exceed 1 meg. So you have 1 meg of storage available to you per application, for your application. And then by default, config maps are updatable. And this is a great advantage over environment variables, as we saw previously, is that you can update them. So that if you have values that may change frequently, then config map is the way to go. You can update them, and then those updated values can be read inside the pod. An admin, however, can make them immutable, and these are in situations where you have tens of thousands of config maps and they're very volatile, change frequently. That could affect the performance of Kubernetes if those values are changed very frequently. So an admin can make them immutable. But for most cases, you don't have to worry about those, and those will be updatable for you. Now let's take a look at the syntax of how we can create a config map from literal, and then I'll show you in the next slide, I'll show you how we can do that from a file. So the syntax is kubectl, create config map, and the name of the config map that you want to assign to it, -- from literal, which means that now the key values will follow. And the first key value we specify for this application is service host name equal, so that is the key, and this is the value server1.acme.org. -- from literal, so we are saying we have another key value object that we want to define, and again we define the key, in this case is service port number, and the value, which is 9001. So once we hit the enter, then we contact the API server, and then those values, the config map that we just created, will be persisted inside etcd. So this is again, we are abstracting the information, config map information, from the pod itself. And then we can define our pod either using a deployment object or a pod object. And then again, under spec containers, we can define in this case, we say an environment from. So env from means that redo these values as environment, and then we specify the name of the config map that we have here, and that is the name. So in this case, automatically, when the pod is created, Kubelet will read these values and from the config map, and then we create environment variables for each. So in this case, we have 2 values, key values, and then Kubelet will create 2 environment variables that we can consume. There's another way you can define those information, and you can explicitly specify the name of each key here, but that becomes a little bit cumbersome. So I prefer this shortcut, which is n from, and then just specify the name of the config map, and then Kubelet automatically reads those for you. And then once we apply and run that, which is kubectl apply -f, again, the name of this YAML file. Again, it goes through API server, which calls Kubelet calls CRI, and CRI creates our pod. And then at this point, kubelet will read this values, config map values from etcd and sets the environment variables over here. And then we have the environment variable set and the application is ready to go. And finally, the CNI will create the network stack for our pods. You can also create config maps from files. And furthermore, you can read those information and mount them as volumes inside pods. So let's see how we can do that. Let's go to the command line and let's create a config file, basically a text file. And let's put a couple of keys in them. So echo service hostname equal to service1.acme.org, and also service host port number equal to 9001. The same information that we used for previous demo. So, but we put them inside a file called key value. So we can then check to make sure that our values are in that file. So we do a cat keyvalues.txt, and then you can see that, yes, they are there. Now we are ready to read them, create a config map, and use them. So let's see how we can do that. So the syntax is kubectl config, create config map, and the name of the config map that you want to create, and then here dash dash from file equal to the name of the file that we just created, which is values.txt. So this is a very convenient way for us to create our configuration from a file rather than typing them one at a time through literals. So once that, we can then submit that to Kubernetes, and Kubernetes create or save that object, which is the config map inside etcd. And this is a partial view of what is created. There's a data section for a config file, and below that is the name of the file that was created. So this will be used to, when you mount them inside pod, it uses the same file name that we used over here when we read them from. You can change that, but by default, it uses the same file name. And then below that, then it has the key value that we specified here. Now that we have this object config map in etcd, then we can create our deployment. Either, again, you can create a deployment or a pod. Either case, under specs, we specify the volumes, because now we want to read them as volumes and not environment variables. And we specify a name for our volume as usual. We call them app1.configmap, -config map, and then config map. This is the keyword that we need to use, and telling Kubernetes that this is, we are reading from config map, and the name of the config map that just created. So that will correspond to the name of this object we created up here. Once that's, then we can then compile that again, kubectl apply -f, and then name of the YAML file. And as usual, Kubernetes goes through the motions, calls, in this case, calls kubelet, and reads the information, and in this case, sees that we want to create this folder. So we mount the information as volume. So actually, first it creates a folder with the same structure locally, and then CRI will create the pod, and then Kubernetes then will create the file locally here, the same format that we specify, the same file name. And also it reads this file over here, file name, and creates a file with that name locally, and then copies everything into that file. Now this file will have the information, all the keys about key values that we specify for our config map. And finally, the CNI will create our network stack. Now the application configuration that we just read from the config map from Kubernetes will be available in this text file, and the application inside pod can then access those and set whatever it needs, configuration that needs to set. It will set it according to the information in that text file. To manage confidential configurations such as passwords, we should use secrets. So secrets are very similar to config maps, but are specifically intended to hold confidential data. We can create them either from literals or file, as the case that we saw with ConfigMaps. And they can be consumed inside pods as environment variables or mounted as volumes. A big caution here is that Kubernetes secrets are not encrypted by default. They're only encoded using base 64. So anyone with the API access can retrieve and manipulate the information. So to be safe, you need to encrypt the information. And I'll provide you one way of you can encrypt the secrets in Kubernetes as part of our demo. Okay, now let's take a look at the syntax of creating a secret. So kubectl, create secret, and then secret type. So generic is one type. There are other ones as well. So generic, they're also called opaque. Basically, any arbitrary user-defined data can be, we can use generic for that. But there are also other types such as service account, Docker files, credentials for basic auth, SSH, TLS, and etc. So based on your needs, you define different types of secret type, and then you specify a name for it, and then -- from, again, in this case, we are creating them from literal, so I'll say from literal equal to, and then the key value is user ID, and then the value for it, DB user, and I define another key value pair from, again, literal, and this one, the key is password, and the value is the value of the password. So then once we compile that, those information is saved into the secret is created, but note that the values are encoded. Again, these are not encrypted, just encoded. And then they will be decoded when you read them back from the etcd. So let's go ahead and then create a deployment. And again, very similar to the previous ones. And the containers, we are specifying that we want these values to be read as environment variables. So env from, and then dash secret ref. So this is the keyword here that tells Kubernetes we want the secret from etcd, and the name of it is inventory cred. So this is the information that we want to be loaded inside pods as environment variables. So once we can compile that YAML file, and goes through the process again. Kubelet calls it to CRI, creates the pod, and then Kubelet then reads the information again and see we want to load this as environment variable, reads those, decode those, and then save them as environment variables. Know that those are available for application to do whatever it needs to do with them. Demo time. So we are going to demo some of the stuff that we learned so far. So the first thing that we want to do is we deploy two services here. Let's say we have an application that has a service and a database. So let's go ahead and take a look at the YAML file for each one of those. So the first one is our service. And then really nothing new here. The only thing we added really new here is adding the environment, the env keyword. So we are going to define a couple of environments here. One is called SV underscore external service underscore host underscore name. Basically, are the name of the service that this application will need to call external service, and then the port number, very similar to what we saw during the presentation. And then we also create a service as part of this, and the pod that we created up here would be included in that service. We also will create another deployment. This one, we call it hello world-db. So this is our fictional database service for our application. And then we define under spec containers And then as you specify the image where it's coming from, nothing new here. And again, under environment, we define a bunch of new environment variables such as DB host, the IP address and port number of the database. So let's go ahead and run those. As you can see, I have on line 5, I have sleep 4. So I want to make sure that this one is the service is created first, and then this one, and I'll show you the reason why I'm doing that. Okay, let's see. Now it's created, both of them are created. Let's verify that on line 10, kubectl get service. Now, as you can see, we have 2 services now created, one for database and one for the service. So on line 10, we are going to capture the pod that is part of our deployment for our service, not the database, but just the service. And so we're going to capture that in that, put that in that variable, and then we can then echo that. So this is the name of our pod, the service pod. And then on line 20, we are going to sh into that pod. So kubectl exec minus IT and the pod name, and basically we say sh. So let's go ahead and do that. And then now we are inside. You can see there's a different prompt. This is now we are inside our pod. Now we want to look at all the environment variable. So this is the command, print env, and then we pipe it into sort. So we want to sort the environment variable. And as you can see, last 2, these are the ones that we created. So these are our user-defined environment variables. But as you can see up there, there are a bunch of other ones. For instance, one is service. So our service, because it was created as part of our deployment, so the pod knows about that because they were created together. Kubernetes also injects other information about some of the services that it creates. However, there's nothing about our database service. The reason for that is because that service was created after this. That's why I put the sleep 4 seconds here to make sure that service, the first service was created first. So our service really doesn't know anything about, the pod doesn't really know anything about the second service. So let's go ahead and exit. And on line 26, let's go ahead and actually delete this pod. So kubectl delete pod and then the pod name. And as you know, Kubernetes is going to now create a brand new pod for us. So let's go ahead and capture that pod on line 30. So we're going to capture the name of our new pod. And then on line 31, we're going to, again, sh into it, but rather than interactively, we're going to actually pass this command. We're going to ask it to show us all the environment variable and sort that. So rather than sh into that, it's a different way of doing things. Sh directly into the pod, we can actually ask the pod to run that command, which is print environment, and sort it for us. So let's go ahead and do that. And as you can see, we still have the all information, and we scroll up. Now we'll see that now the database service is also included here. So so this is the information we could use for service discovery, but as you can see, this is not very accurate because if all the services that are created after the pod are deployed are not reflected here. So a better way is to actually use core DNS name resolution. I covered that in a different video. I'll provide a link up here. You can click on that if you want to get more information on how to do that. Okay, now let's go ahead and delete the database service and the service, the pods and the service on line 34, kubectl delete -f deployment hello world db, which is this guy here. So let's go ahead and delete our database services. And then if we go back to the pod line 38, kubectl exec minus IT, and we are again pointing at our pod service and run the same command, print environment sort. So let's go ahead and do that. And as you can see, even though we deleted the database, but this pod doesn't really know anything about that. That doesn't know, is not aware that the pod or the service has been created and it's still showing us the service. Okay, so let's go ahead and delete this service also and get ready for our next demo. In this demo, we are going to work with ConfigMaps. So the first config map that we are going to create is from literal. So on line 25, create a config map, and this is the name of our config map. And then we're saying from literals, that is the key value follows that. So the first key would be external service underscore host underscore name equal to service1.acme.org. And then we follow that with another literal, and this one followed by SV port number equal to 901. So let's go ahead and create that. And we'll see that that was created. Now we're going to next config map, we're going to, that was for prod. Let's go ahead and do that, create another config map. This is for a staging environment. And rather than from literal, let's go ahead and actually read it from a file. And this is the file that we're going to use. So again, we have the same similar information. The service name, this one will be .stage, server1.stage.acme.org. And the port number in this case would be 9002. And if we again cat that, we'll see get the information that just we saw. Okay, let's go ahead and now create that. So kubectl on line 33, kubectl create config map. And this is the name of our staging config map. And then from file this time, up here we have from literal, from here we have from file, and then that is the file name. So let's go ahead and execute that as well. So now we have two config map that we can work with. On line 38, let's take a look at, let me just clear this for now. Let's take a look at the both config map that we just created, and we're going to show them in YAML format. So let's go ahead and run on line 38, kubectl, config map inventory, minus O YAML. So this is the name of, this is what we get. And we'll see that, let's just bring it up here. The version, and this is the two keys we just created. And then we had some of the information such as timestamp and so on, the name of the config map, version, and so on. So let's go ahead and do the same thing for the stage. So remember the stage we created from a file rather than a literal. Let's see what the difference is. So it's basically more or less the same information. The only difference is under data, we have the name of the file. So that is saved as the key. Again, we can change that if we want to as part of the command line when we create the config file. But if we don't do it, it just it saves the name of the file that was used to create it as kind of the key. And that is what it's going to use when it loads the information into the file system on the pod. It will actually create a file name with the same name, and we'll copy this information into it as we saw during the presentation. Okay, let me go ahead and clear these. Okay, let's go ahead and now do a couple of deployment first. On line 43, kubectl apply -f, and this is our prod deployment. So again, the number of replicas is 1. Again, nothing really new here, and the only difference with everything that we've seen so far is and the containers, and then environment from, and then dash config map rep. This is exactly like we saw in the presentation And this is the name of the config map that is created for our pod config map. So let's go ahead and run those. So we're reading those as environment variables. So on line 46, again, we're going to capture the name of our pod that is associated with our prod deployment. Let's go ahead and do that. And we can print it out. So this is the pod name. And then we can then SH into it. And then like before, we print the environment variables. And as you can see, these are the two environment variables that we created for our prod deployment. So let's go ahead and exit. Now, let's do a different deployment now for the stage environment. And so this is the stage. Again, this is very similar to the prod. The only difference is under containers, we are going to mount them as volumes. So we have a volume, and then the name, inventory, stage. So sorry, first of all, we need to look at the volumes here. So we have a name for it, and then config maps. So this is the keyword that tells Kubernetes we want to load them from a config map, and this is the name of it. And then that corresponds with the name up here. And then we specify where we want to load it. This is the mount path. So this is where Kubernetes is going to load the information into the file system on the pod in this location and copy everything from the config map. Okay, let's go ahead and run that as well. Now let's go ahead and capture the name of the pod that is associated with our stage now. Let's go ahead and capture that and go ahead and echo that. So now this is a different pod name. On line 61, kubectl minus kubectl exec minus IT, the pod name, and so we're going to SH again into the pod. Now this is the mount path, if you recall. So this is where we told it to load the information in this directory. So let's go ahead and verify that over here. So ls, and in this location, we see now that we have a file with the same name that we specified, that we loaded from, the information from, so that actually created that. So let's go ahead and take a look inside this file, on line 63. So we do a cat on that file. And again, so no surprise, these are the two keys that we set. So that is as far as looking at information inside these two variation. One is using environment variable, and the other one is using the mount them as volumes. Now, let's go ahead and do something here. Let's go ahead and on line 68, we are going to edit the file, the stage config map. So kubectl edit config map and the name of our stage. So I'm going to make a change. I'm going to change the port number from 2002 to 2004. And then we'll watch what happens over here. Let's go ahead and get into that. So we are now going to inside here. So I need to get into insert mode, and I'm going to change that to say 2004. And I'm going to now do, and then save the information that edited. So let's go ahead and get into that. I'm going to watch, we're going to watch this information, because now this has the old information. Service port is 2002. It will take a couple of minutes in order to information to be updated, and then it automatically updates the file here. And now, as you can see, it changed from 2002 to 2004. So that is the advantage of using ConfigMap, is that we are able to, when the information updated, then it also updates the information inside our pods. Let's go ahead and clean up and get ready for our next demo. In this demo, we are going to look at secrets. So let's go ahead and create a secret on line 3, kubectl, create secret, generic, so that is again the type, inventory, so that's the name of our secret, and then we have from literal. The first one is the user ID, and the second literal is the password. So let's go ahead and create that. Then we can verify the secrets was created correctly. So on line 9, kubectl get secrets, and this is our inventory secret right here. We can also do a describe to get more information. So on line 13 describes secret and our secret name, which is inventory. So let's go ahead and do that. And we'll see that here under data, we have the user ID and the password. However, it doesn't show us the value. It only shows the length of those. So in order to actually get at those on line 18, we need to actually do a little bit of work. So kubectl get secret inventory, and then we have to say dash dash template equal to, then data dot user ID. So we are kind of getting inside this document in etcd. So this is the data and this is the user ID. So that's how we get that. So when we do an echo on that, we'll see that this is an encoded, not encrypted again. So it's an encoded value for our user ID. So if we then on line 18, we pass that to base 64. So really it's really not very secure. It's only encoded in code base 64. So if we decode that, then we get our user ID, DB user ID. So that's the value. Same thing for the password. So the first value on line 21, we're only getting the encoded value for password. On line 22, we pass that value to a base 64, and we get our password here. Okay, so let's go ahead now and do a deployment here, and we are going to, for this demo, we are going to read the secret value or secrets in terms as environment variable. So again, this is a deployment, and number of replica is equal to 1. So everything really is the same, nothing new here, except on the containers, we have environment from. So we are saying that we are getting our environment from and values from, and this is dash secret reference. So we are using secrets, and the name of the secret is inventory. So that's about it. Everything else really normal deployment. So let's go ahead and run that. So you see that that's created again on line 29. We're going to put that, extract the value of our pod and put it into a variable. And then we can echo that to make sure we got the value for it. And so this is the name of our pod. And then on line 34, we are going to sh into our pod again, kubectl exec -it, pod name, and then -min sh. So let's go ahead and do that. And now we are inside our pod. And then let's take a look at print on line 35, print environment, and then we want to sort those. And then if you look at the value, we have our password and our user ID. So that's what we specify in our secret. So when the values are read from etcd, they are decoded, and that's what we get the value actually now inside environment variable. So let's go ahead and exit out. Let me clear this. And then we do the same thing now. We put the secrets inside file rather than environment variable. So Again, everything else is the same as far as creating a deployment, specifying the number of replicas, specifying the labels and everything else. So that nothing really new here. Under volumes, we specify a volume name. We call it app secrets. And then we say secrets. So this is basically kind of signaling to Kubernetes that we are interested in acquiring a secret from etcd. And then this is the name. So this is the name of our secret, which was inventory. And then under volumes, we specify a path for that. So where we do want the secrets to be loaded. So it should they will be loaded under /etc. And then this is app secret. So let's go ahead and run that. Now it's created. We can again on line 42, we extract the value of our pod name that was just created, that deployment. And then we echo that out and line 43. So that's the name of the new pod. And then if you describe on line 46, the kubectl describe pod and pod name. And then we can find under volumes here, we'll get a little bit up. And then environment and volumes, you'll see that this is where we set to mount the volume on. So this is kind of matches that with this file. So this is kind of confirmation that it was loaded into the pod. So we can actually now go inside the pod on line 49, kubectl exec minus IT, pod name, and again sh. So we go ahead and sh into that. Now we are inside pod. And then we can look at the folder on where the secret was supposed to be loaded. So ls on line 53, ls /etc, and then the folder name is app secrets. And we'll see that now for each one of our secrets, Kubernetes created a file, so a folder for each one of those. So if you align 45, sorry, a file for each one of those. So on line 54, we can take a look at cat, etc, app secrets, and user ID. If we do that, you'll see that this is a value, db user 1. And then we do the same thing on line 55. So we'll run that, and this is our secret. So those values are read inside and put into the in two different files inside that directory that we specify. Okay, that is as far as secrets are concerned. In this demo, we're going to walk through the process of how to encrypt our secrets in Kubernetes. So let's start off by looking at our secret that we created in the previous demo, and that was inventory called inventory, secret called inventory. So kubectl describes secret inventory. Let's go ahead and run that. And if you recall, we had under data, we'll see user ID and password. So right now there are encoded base 64. So those are the two values that we were interested into as our secret. Now we want to verify that this the secret is not actually encrypted. So what we could do is directly go through etcd through API server, and this is how we interact with the API server through etcd. So etcd-ctl, this is the command line that we need to use. We need to specify the API version, which is right now version 3. We need to specify the endpoint and the port number of our master. So the endpoint is, again, the IP address of the master, and 2379 is the port that Kubernetes, the API server is listening on. By default, it's 2379. And then we need to specify or present our credential, the credential that we need to be authenticated. That is what Kubernetes itself uses to like kubectl and other command line to interact with the API server. So we need to specify on line 6 the PKI certificate. So, and this is the where it location is, the PKI key and where it's and its location, and CA certificate and its location. So this part is our submitting our credentials. And then on line 9, this is the actual command that we need to run. Get registry secrets. Default is the namespace name, and inventory is the name of our secret, and then we dump it in as hex. So let's go ahead and execute this. As you can see, if you look at towards the end, we'll see that this is our password and its values is not, obviously we can see the value here, and also user ID, and we'll see DB user 1. So we'll see none of this actually encrypted, so which is not good. If a hacker had an opportunity and had access to those certificate and key, it would then he or she would be able to actually get inside our etcd and look at our secrets. So we need to encrypt those. So the first thing that we need to do, I provide the steps on line 14. First of all, we need to generate a 32-byte random key and encode it. So let's go ahead and run that. So this is the command line at head -c32/dev/your random, and then we need to pipe it into 64. So kind of encode it in 64. So this is the value. So obviously when you run it, you'll get a different value. This is totally random. Then we need to create a encryption configuration file. I've created one as a sample you can use. So the key that you created down here, you need to copy and paste it under the secret. There's the name one or keys under keys name, key 1, and then you can then paste it here. So I'm going to use what I've already generated, so I'm not going to change that. In your case, I recommend doing that. And then we need to copy this file into this directory, etc Kubernetes PKI. So make sure it's copied there. I've already copied that, so I'm not going to do that. And then we need to edit. So on line 21, I explain edit this file, cube-api server.yaml, which is under here, etc Kubernetes manifest. And this is the YAML file that we need to modify and add the location of that file inside that. So this is the line I needed to add to that. So encryption, that dash encryption provider dash config equal to, and then the location of the YAML file we just created and copied in that locations. So let's go ahead and take a look inside this. And then if you scroll down, then you can paste it in the last line here. I've already done that, so I'm just commented to see that. So this is where you need to copy that line here and paste it over here. And then you save it. And the documentation recommends to restart the server. In my case, I didn't have to, but if just to be sure, just go ahead and reboot the master. And then on line 27, let's go ahead and look again and see if everything is in clear text or not. So let's go ahead and do that. And we'll see that, well, it's not encrypted yet. So we need to do another kind of extra step here. And on line 32, I explain, since secrets are encrypted on write, to encrypt all, performing an update on a secret will encrypt the content. So on line 34, we are going to actually regenerate the secret. So kubectl get secrets dash dash all namespace minus o JSON, and then we pipe it into kubectl replace minus f. So we're going to replace all our secrets now. And once those are written, then the new secrets all will be, or the regenerated secret will be all encrypted. So let's go to that, and we'll see that it replaced a bunch of those. Not only our secret, but everything else that was created. All the secrets that were created by Kubernetes also. So now on line 38, let's go ahead and see if now our secret is encrypted. So let's go ahead and we'll see now, we don't see those values anymore. Everything is encrypted. And also, I explained it here, we need to look at, make sure that this value exists. So KA, AECBC, which is the algorithm encryption, algorithm V1. So this is the one, K8, BC V1. So this is the kind of verification that everything is encrypted. By the way, sorry, I forgot to mention, one of the things that we specify here is first of all, the resources, the kind is encryption configuration. The resources, we want to encrypt secrets, so we specify that. And providers, under providers, so this is the provider. So this is the encryption algorithm that will be used to encrypt the keys. I also specify if you change your mind and you want to decrypt everything, then you need to uncomment this line and comment this. So the line, the first line should be before this, everything below it has to be this line. So uncomment this line and comment this line, and then save it, copy it back to that location again that we specify up here, and then reboot your server. And then once that's done, then you need to again run this line on 34 to regenerate or decrypt. Running that will decrypt everything. So obviously, I'm guessing if you are going through the trouble of encrypting your secret, you're not going probably to decrypt them again. But if you have to, this is the way to do it. And one more note, I provided the steps that you need to take in order to rotate the key, because obviously you don't want to use the key that you generated for encryption for eternity, because at some point you want to rotate them, and you need to do it manually to generate a new key. And I provided steps through here, so just go ahead and do that. Before ending this video, and for the sake of completeness, I want to talk about another way that you can encrypt secrets in Kubernetes is to take advantage of a key management service provider. So in the last demo, we saw how to encrypt data by generating a key on the API server, and then use that key and have Kubernetes encrypt the secrets. The problem with that method, the only problem with that method is the key also resides on the API server. So in case that the server becomes compromised, then the hacker will also have access to that key. So by using a KMS provider, the key will be won't be on the API server anymore. It will be managed outside Kubernetes environment. And that is more robust, more secure, because the hacker will need to compromise both the API server and the KMS provider. The KMS or key management service is a little bit beyond this course, but most major provider, cloud providers such as Azure, AWS, and Google provides KMS services. And there is a plugin that you can use with Kubernetes, and then that will then provide automatically, will encrypt very safely and securely. I'll provide a link as part of this in the description. You can take a look at that. Also, you can create your own KMS if you have the resources. So I just wanted to throw this out before ending this video. So thank you very much for your time, and I hope that it was useful. Thank you. Bye.